A particle is moving with the given data. Find the position of the particle. A sub t is equal to t squared minus 8t plus 3. And we're also given s of 0 is equal to 3 and s of 1 is equal to 20. So before we actually jump into the problem, let's start talking about just some notation. So s of t is what we call the position function of an object. The first derivative of s of t, s prime of t, is also known as the velocity, and also known as the velocity v of t, denoted by it. S double prime of t is the acceleration of the function, or also known as, or the second derivative of the position function, which is also denoted by a's of t. So with that being said, the integral of the second derivative, a's of t, is equal to the velocity, or the first derivative, s prime of t. But we also add a constant because there is an infinite amount of constants in the world of mathematics that will make the derivative the same. And as we see here, or plus s prime of t. And then the derivative of the first derivative, the velocity, is equal to the position plus c. Same reason. So, to be able to find this, we're trying to go from a of t to s of t. So to do that, we need to integrate the function of a of t, and then integrate the function of v of t. All right, so the integral of a of t dt with respect to time, because we're using time as our variable, is equal to the integral of t squared minus 8t plus 3 dt. So using the basic power rule, because this is a polynomial, the velocity as a function of time is equal to, move this over, sorry guys, the velocity is equal to t cubed minus 3 minus 8t squared over 2 plus 3t plus c1. All right, because we're going to be integrating this function twice, I denoted c's of 1 and c's of 2. If we integrate multiple times, I use different kinds of c's to denote different constants. So cleaning this up, we get the velocity as a function of time is equal to t cubed minus 4t squared plus 3t plus c1. So we're going to integrate that again. V sub t, the velocity as a function of time, is equal to the integral. The integral of that is equal to t cubed over 3, integrated of course, minus 4t squared plus 3t plus c1 with respect to time. So the position of time is equal to t to the 4th minus t cubed plus 3t squared plus c1 t. All right, because this is the constant, we add a t now, plus c to 2, using the power rule again, of course. And so now we need to find c's of 1 and c's of 2. So we're going to use, so the easiest one to find first is c's of 1, or c's of 2, because it's the constant function, using s of 0 is equal to 3. So we plug in 0 for all t's. So 3 is equal to 0 to the 4th over 12 minus 4 times 0 squared, or cubed, over 3 plus 3 times 0 squared plus c's 1 times 0 plus c's 2. All these terms go to 0. Sorry guys. All those terms go to 0. So therefore c's of 2 is equal to 3. Plug that into the function. T to the 4th over 12 minus 4t cubed over 3 plus 3t squared. Oops, I wrote that twice. Sorry, guys. Sorry, I wrote that twice. You guys couldn't see what I was doing. But plus c is 1 of t plus 3. Alright, so using the same logic as from the first one, we're going to use, to find the c's of 1, we're going to use this one right here, s of 1 is equal to 20. So 20 is equal to 1 over 1 to the 4th power over 12. Plug in 1 for all t's. Minus 4t cubed over 3 plus 3 times 1 squared over c1 times 1 plus 3. So we do all these. So all this is simplification. All right, solving for c1, we find c sub 1 is equal to 183 over 12, and we plug it back into the to our position function. So, and that gives us, that should be a t right here. Sorry guys. S of t, the position with respect to time is equal. I usually use x of t, but the problem gave us s t to the 4th over 12 minus 4t cubed over 3 plus 3t squared plus 183 over 12t plus 3. So this was an application of using integration. If you guys remember from earlier derivatives, we found velocity and acceleration given position. Well, we're just undoing that using concepts you guys used in early integrals. See you guys next video.